Afternoon, everyone. All right, cool. So my name is Chatan Mistry. I work in corporate and consumer IT in the solution design team. I work for Chris Dale, who's just walked in late. So there's a couple of seats at the front here as well. Awesome. So I'm going to spend about 10 minutes talking about what blockchain is. I'm going to try and give a simpler view that hopefully everybody will understand. I have got some more slides that go into more detail, but I don't want to give people a headache, to be honest. So if you want those details, I can speak to you afterwards. So hopefully by the end of the time I've spoken to you, you'll understand what blockchain is, how it works, and why it's considered as a disruptive technology. But in order to understand what blockchain is, we need to understand how we do transactions today. So this is my naughty example. Simon asks John to lend him £50. John says, yeah, that's fine, because I'm a good friend, I'll lend you £50. John has to speak to his bank manager, because the bank manager and the bank has his money. And so he checks with the bank manager, says, can you give Simon £50? The bank manager says, let me have a check at your bank account. Checks that it's there, checks the balance is fine, and so he transfers the money, updates the balance, and he writes into his account the transaction. Does everybody see that? Is that right? Pretty simple. That is how the current banking system works. So you have a bank manager, and he is your trust. You trust the bank or the bank manager to look after your money, to look after the transactional aspect of your account. This is great when everything works, right? So you've got, but the problem is that sometimes it doesn't work, and sometimes the people that we trust let us down. You know, in the UK we have a heavily regulated industry, so it is the government oversees it. In some other parts of the world, it doesn't work like that, and so blockchain is really good for when there is no trust. So now that you know how it currently works, I can kind of go into a bit more detail about how blockchain works. So it is effectively a distributed ledger with a self-governing way of verifying information that's stored on it, and it's deregulated. So once data is added to it, and it's verified. So when data is added to it or a transaction is added to it, it is verified. It cannot be added or deleted, cannot be modified, and the system itself regulates it. So there's no overarching company, there's no single point of trust. The system itself, because of the way it's been built, regulates and makes sure that everything is valid. And probably the most important aspect is that it's distributed. So there is, not only is there no single point of trust, everybody has a copy of the ledger. Everybody involved in the chain has a copy of the ledger. And that's not usually like 10 or 50 people. You're talking like millions of people, thousands of millions of people, depending on how many people are in the chain. And it's that duplication and that sheer volume of people that have it that makes it work. So it's made up of a number of components. It's got transactions, so the item on the ledger, and we'll go through an example in a minute. Each of those transactions is stored on a page. Each of those pages has a certain list of transactions that it can store, and then it's put into a folder when it's full. And then it's obviously, the whole thing is kept on nodes or computers, which is distributed. Are we good so far? Oh, it's not quite the same. Are we good so far?
Yeah.
Cool. It's going to get harder. Sorry. So here's an example. Hopefully the example will help you understand a bit more. So here are 4 people who are part of a chain. There's actually 4 chains there. So Alice has got a Brenda, Charles, and Debbie's chain, and so that's why there's 4 individual pages there. But for the sake of this example, we're going to look at the Alice. And Alice wants to give Brenda £10. So the first thing they do is they make sure all the participants in the chain make sure that Alice can give Brenda £10. So they check that they've got Alice has got £10 in her account, effectively. All of them do that. So if there's 1 million people in the chain, all 1 million people will do that, and all of them have to agree to do that. They then all write it in the ledger. So now you've got all the ledgers are the same. They've all got the same transaction in there. They'll all update their balance. And then what happens is there's probably other transactions that happen. So what they do is they all write those as well. So all 1 million people in the chain write all 10 transactions, and that's quite a lot of work, but that's how it works. So you have 1 million people with a list of these transactions, and because all of them verify it every time a transaction is made, all of them have been checked and all of them are accurate. But once you get a certain number of transactions, the page literally gets full. There's nowhere you can add any more. So what we need to do is we need to seal the page and put it away. And this is where it gets complicated. But I'm going to simplify it. So when you seal a page, you're doing two things. What you're basically saying is that the page is full, and you can't add any more transactions to it, and you cannot modify it. And the second thing it does is it adds it to the chain. So once the page is full, you effectively are sealing it. Literally, in the old-fashioned days, you've got a wax. You fold it in half. You sealed it. You cannot open it. Cannot be opened. And then you add it to the chain, or to the folder, as I called it, and it cannot be modified. That process is complex and it's time-consuming. It's very mathematical, and I'm not going to go into the maths. But the technical name of it is called mining. So if you've ever come across blockchain, you might have come across the term mining. That's what it is. The mining is the process of sealing a page and putting it on the chain. And it's very time consuming. As in it takes a lot of computing power. Does that make sense? Good, I'm getting lots of nods, great. Okay, so once a page has been sealed, it's added to the chain and a new page is started. And a new page is started. Having multiple or millions of copies of that chain reduces the chances of it being changed, but it doesn't eliminate it. But the chances of breaking it are very small, just because of the sheer number of people that are verifying each step that happens. And there are some things that happen that help minimize any errors. So the first thing that happens is when a page is full, there is an algorithm that runs on the page and it generates an ID. And that ID is the same across all 1 million or 1,000 people in the chain. They all run the same algorithm, they should all have the same number, and they all check that they get the same number. So that's one way that you can check that all the transactions are the same. If one of them disagrees, then that person has to throw theirs away and use the other 999,000.
But did you just say it's not 100% error-free?
It's not 100% error-free, and I'll come back to why it's not a bit later on. But this bit of it is error-free. The second piece is that because the seal is added, it cannot be changed. And what happens is, when it's sealed, the seal itself is generated. One of the inputs that generates that seal is from the number of the previous chain. So effectively, it needs to know the number of the previous chain, and it adds it in to generate the new chain. And so what it means is that the current block is dependent on the previous block. And so if you've got somebody who's added a block, it won't work because the block number will be different. So you can find out if somebody's tried to modify an entire block. So you've got a way that somebody finds out if the transaction has been modified. You've got a way that makes sure if somebody's modified or added a block at the end of a chain. Are you with me so far? Yeah? Okay. And then you can't add a block in the middle of a chain. So if you've got a chain of 10, you can't add one in the middle because the sixth one was already dependent on the fifth one. If you add one in the middle, then the sixth one's going to be wrong. And so that's how it. And so that's another way of it checking for errors. And so what happens if somebody tries to do that? They will delete that sixth block, the one that's superfluous. Good. So that is my very quick summary of blockchain. Told you it was quick. It's a distributed ledger that is replicated across thousands of millions of nodes. There is no single database, no single master record. It is unregulated by any single bank or any government, which is quite scary for some of the governments out there, but it is. That's just the way it works. It's made up of transactions that are written on pages, which are stored in a folder. So it's made up of blocks and made up of chains. And it's self-checking. So it checks itself out. So it is very secure, and it is reliable. So, do any of you guys know John Oliver? So he did, funnily enough, this week he did a whole talk on Bitcoin and blockchain. And I've just stolen a bit to help you understand why there is an error in there.
Many people believe that the really exciting thing about it is the potential of the innovative technology that it's built on, and that's something called blockchain. Now, normally, if I wanted to send money to someone across the world, a bank would need to verify that transaction, and it could take days. But with Bitcoin, it is vastly faster because no bank is involved, and that is because blockchain technology allows a record or a ledger of every Bitcoin transaction ever made to be stored not in one place, but across vast numbers of computers. That is part of what people mean when they say Bitcoin is decentralized. And decentralization has a lot of theoretical advantages, from speed to security.
The key point here is that this is a distributed ledger. There is no central server. All the other ledgers that we have, all banking ledgers, all company ledgers, they all sit and reside inside that company, which means they have one point of attack. They can be hacked. JP Morgan was hacked by cyber thieves not so long ago. Home Depot, Target, we've had all these companies get hacked precisely because there's one central repository of information. The Bitcoin ledger resides on thousands of computers. You can't hack that.
And when you think about it, that sounds great. And because of the complicated process the network uses to verify records, it is very secure. Now, relax. I'm not going to get into what that process is or how it works, but I will share a really helpful, really dumb metaphor for why it is safe.
The way I like to think of it is that a blockchain is a highly processed thing, sort of like a chicken McNugget. And if you wanted to hack it, it'd be like turning a chicken McNugget back into a chicken. Now, someday someone will be able to do that, but for now, it's going to be tough.
Hold on. That is an absolutely horrible thought. So why is that reporter so happy about the idea?
That's an understanding of blockchain. You'll never look at chicken McNuggets ever the same.
Thank you very much, Chetan, and thank you all very much for being here. It's always great to see so many people interested in what Anton and I spend many hours of every day working on. Just to give you a little bit more background to ourselves, we both sit within the Centre of Excellence at KPMG UK. This is a recently formed body within the firm to focus on commercialising the blockchain for the UK market. We essentially are developing our UK strategy and also helping our clients with their wider digital transformation. So across the globe, we're active in about 30 countries now with regard to blockchain. So without further ado, just to give you a brief overview of what we're going to cover. Anton is just going to build on our introduction, and then we're going to look at some applications within healthcare, within insurance, and also loyalty wallets as well. And we'll have time for questions at the end. So I shall firstly hand over to Anton.
Thank you, Lauren. Hi everyone, my name is Anton Christoph. I'm part of the UK blockchain team. Because we saw the slides previously and I wanted to make your life more complicated, or at least to maybe simplify this, and just a couple of slides to emphasize on what the blockchain technology really is, because we saw the Bitcoin element, which was the first working use case, which is a great example that this technology can really work. But the possible implications and applications of these technologies are vast and huge. That's why it's so disruptive. So, right, we saw how Bitcoin works. So it's a decentralized network of peers who are exchanging or transacting between themselves to exchange money, or not money, but a digital form of something, which most of the people on this planet are calling it a bubble. So basically nothing is backed up, but just a promise where everyone can really make things happen. The beauty of the technology, though, the blockchain or the so-called distributed ledger technology, is that in a simple, non-technical, non-business words, maybe, I love to kind of say that it's a club or a network. So, like the club structure, especially here in the UK, we do have the public clubs, which are open for everyone to walk in, have fun or attend, or simply take the benefits of this network. Or we have the private club structure, which is more restricted. It has a thorough constitution, so it's a closed environment, so you should be invited to participate, you should have a role responsibility within this club, etc., etc. And that's how blockchain really works as well. So we have the public blockchain space, which is more or less the cryptocurrency space, with the likes of Bitcoin, where anyone can jump in, create an address or a wallet, as they love to calling it, and start interacting or exchanging value with these cryptocurrencies. But we also do have this private and consortium type of blockchains, which are more interesting, especially for the business and the enterprise usage. And I'll tell you why. So the consortium blockchain is based maybe an industry-wide solution, or companies operating in the same space can decide and say, hey guys, we'll need to operate more efficiently and more transparently, or let's collaborate, right? This is the modern words of the 21st century. It's all about collaboration, it's all about improving efficiency and the reducing operational costs. So they create a consortium-based blockchain, which is still based on a consensus mechanism where you are flexible to decide the rules of the game, let's call it. So the constitution is dependable on all its members to decide which are the rules and how this network will operate. And this doesn't necessarily mean exchanging money or transacting. It could be a kind of interaction. Let's talk about interactions. So let's talk about daily life, let's talk about exchanging information, exchanging emails, agreeing on something, or basically executing your day-to-day business and even activities in the public space. And we do have also the private blockchains, which are more interesting. These are the so-called permissioned or restrictive spaces. So imagine having an internal network or closed intranet where you are the organizer and you can say, right, I will invite my closest peer group and I will work with them to establish the rules, what we are about to interact on, exchange information, or why not transact even. So simply put, does this make sense? And on a funny note, I love to say that blockchain is like a club, and for me it's like Fight Club, if you remember this movie. So the first rule of this Fight Club was don't talk about blockchain. So it's all about trust, it's all about collaboration, it's all about what we do on our daily life in our social and economic environments, and can we do it in a better way, more efficient way, more transparent way, where we can really bring back the lost trust somehow, where we can say, right, if I want to do something, I don't need to chase this person like hell each and every day, sending emails, calling him. We might pre-agree on this. We'll codify this in the so-called smart contract, which is nothing more but a simple script or programming language, a software, a program that kicks in and help you do the things better. Pre-agree on this, codify it, and when I send an email to Lauren, the smart contracts will read the email and will know what to do and can automate the processes on behalf of myself, Lauren, and rest of the peers. And it's also quite important to know what the network looks like, what are the participants, their purpose, and what's the aim of this network. Again, a bit of like the foundations of the technology. You've seen this through, but these are kind of the basics. So it's a distributed network. So we are kind of going one level up. So instead of having a central source of truth or the central database, which all the ERPs and the modern solutions are leveraging, with all the peers are logging in into a central system and plugging in the necessary information, it's a distributed way. So with the likes of the Bitcoin blockchain network, everyone has a copy of this ledger, or I love to call it an event log or a message hub, because a ledger means that we are transacting, but it might be an interaction, it might be exchange of information and documents. So it's not a ledger, it's just an event hub. You will, each and every member of this network will see what's happening, what's going on, and will kind of validate it as it happens almost in real time. And it has a lot of possibilities in the public and private space, so it's really a vast opportunity. Again, this is the biggest challenge and issue here, the identity. That's why everyone is so scared, especially with the cryptocurrencies, because you're completely free in this public blockchain domain to call yourself whatever you like. No one is doing KYC, AML, no one is making sure that you're a credible person and you're not a terrorist or you're not a drug trafficker, etc. Whilst in the private blockchain space and the consortium based, it is a must to know with whom you're interacting. Timestamped, as we saw this, it's written on stone, whatever happens, it has a date and stamp, everyone sees it and approves it. All network participants agrees that this event or transaction has happened, so this avoids a lot of reconciliation. Maybe in 20 years, the reconciliation will disappear, as well as the, let's say, best practices in audit recently might disappear as well, because if you have a system that pre-validates and everything happens as it appears on the website, so we don't need auditors to walk in and say, okay, right, so give me all documents and all the transactions, let's review and see what has happened in the past 12 months. This will be in real life, real time. Maybe the auditor will be a participant on the network and will just have to validate on certain rules and procedures. Yes, I agree with this. This is according to all the laws and regulations, or some of the small transactions might happen completely automatically. Also, the tax authorities might have an access to it. HMRC, for example, loves the idea of blockchain. It's brilliant for them. They said, well, we can jump in and see what's going on. The smart contract will automate the tax collection, so it's a brilliant system. Let's have it today. Immutable, you can't change it, as we saw it in the Bitcoin blockchain example. No one can go back in time, modify something, because this will break the chain. So everyone will see who has done this, maliciously changing the ledger, which will break the whole chain. And they can, as consequences, yes, it's secured, because it's crypted, this complex math model, which kind of takes all the information from this page and simply creating an alphanumerical line, cannot be broke right now, cannot be break right now. We'll have an issue when the quantum computing comes in, because we'll be able to revert the chicken McNugget into a chicken. So we'll still have 5-10 years to enjoy the chicken McNuggets. And again, it's programmable. That's the biggest benefit. This was invented by these Ethereum Alliance guys, which said that, okay, it's fine, Bitcoin and blockchain is great, it's really working, but can we do more with this network? Can we implement pre-agreed procedures, contracts, interactions, and make sure that they happen without us being there each and every day? A bit of statistics. Increased efficiency, this is from a pure business perspective, improving efficiency, reducing costs, better customer experience, because the technology itself, the beauty of it, that it's not a front-end technology. Each and every one of us should not know that they're using blockchain. the front end is still an app, a portal, a website, which will help you have the visibility and be sure that whatever you agree or want to achieve is happening and you have a copy of it. And of course, reducing reconciliation, but we have mentioned this. And handing back
Thank you.
the control to Lauren to showcase you a bit of two interesting case studies that we're currently working on and have experience for as well. She will showcase the insurance one and a snapshot of healthcare and also an interesting digital wallet type of platform, but not with the crypto context, but more like a tokenized concept.
Thank you, Anton. I think it's always useful to bring the technology to life with case studies. So to start with, as mentioned, I'm going to look into healthcare. So there's been an exploration into a range of interesting use cases in this space. Here are just a few. In particular, claims and adjudication. So reducing fraudulent and admin costs associated with the automation of the process. So again, reducing the need for intermediaries, reducing the cycle time. We'll discuss this further in the presentation later. Second point to raise is the electronic health records. Third point as well, very key one, is supply chain, so drugs provenance, for example. Blockchain can essentially help to reduce the counterfeit drugs in circulation today by having a chain of custody log, essentially proving ownership. And finally, clinical trials as well, an important one to note. So blockchain can help to increase reporting, to increase the sharing of results, to ensure that this is reducing the safety issues for patients with regard to this, and to reduce the knowledge gap for stakeholders and policymakers as well. So what does this actually mean for the end customer? So this results in enhanced data security, increased transaction speed, and therefore an improved overall customer experience. Now to jump into insurance, there are potential benefits to use blockchain across the insurance lifecycle. Again, some of these key customer benefits being the increased traceability and accuracy of products, data visibility, again, increased consumer satisfaction resulting from this, resulting in higher levels of customer retention, lower policy costs, the development of new services and products, and again, faster payments. So again, it's important to note that this end user experience is at the centre of everything that's being developed within this space. So to jump into prior authorization and claims adjudication, why would we want a blockchain-enabled solution? So again, we come back to what we were mentioning earlier, this increased trust, visibility and efficiency, these transactions are secure and verifiable, and there's access to complete data. So to put this into context further, in the case of blockchain-enabled prior authorization, the clinical data aggregator, which is based on the blockchain, will take the data from the payer's needs directly from the doctor's electronic medical record. This then delivers it to the payer in near real time in the format required by the payer. In stage 2, the integration into the payer's medical management system accepts the data to start the process. And then in stage 3, providers may be exempted from prior authorization, or they can use their electronic health records to provide the summary required in order to provide this prior authorization. To look into claims adjudication a little bit more, this automation component of the claims adjudication is based on something called smart contracts, which we briefly touched on earlier. So these smart contracts are self-executing contracts based on the blockchain. So essentially, information is fed into the blockchain network, which triggers the execution of specific clauses if certain conditions are fulfilled. So again, we can see the process here broken down. So the payer and provider agree to contract, which is deployed on the blockchain ledger. The patient enrolls in coverage with the payer. The patient receives the services from the provider and the improved estimate of costs. The provider submits the claim, and the payer adjudicates and pays the claim in near real time. And then finally, the patient has visibility into near real-time tracking of updates to claims and medical expenses. Again, via this kind of portal or other means, whether that might be an app, for example. So just to jump a bit further into one of our KPMG case studies. KPMG have developed a value proposition for a hospitalisation insurance product. In the instance of hospitalisation events, the product provides immediate payout through smart contracts. So this working prototype, which was developed with BlueZell, explores how hospital data can be utilised to generate a supportive customer experience with no required intervention from the customer themselves. Again, throughout the development of this prototype, the customer journey was at the centre of this, and the needs of the consumer were mapped throughout. So again, ensuring that this is very much customer-centric. In the interest of time, I'm going to skip through this one and just jump to our last one. So, loyalty wallets. So this is... Ooh. So this is a proposition that was developed with Singapore Airlines, with ourselves. KrisFlyer is the frequent flyer program of Singapore Airlines. So essentially, this is a blockchain-based loyalty wallet. Merchants are easily onboarded into this, and consumers can transfer points from their third-party loyalty programs. Customers can then make purchases with their KrisFlyer miles at participating merchants via QR scanning, for example, Starbucks at the airport. So to look into this further, why would this need blockchain? So again, goes back to reduced costs, increased transparency via the flow of information to the ecosystem partners, the simplified onboarding of partners, and increased interoperability between loyalty programs and systems without the need for intermediaries. So what does this look like for the consumer? So just to run you through the step-by-step process of this. The customer will download the KrisFlyer wallet app and log into this wallet with their membership number and PIN. The customer is then directed to the home page and able to see their KrisFlyer miles balance and participating merchants. The customer can then link their KrisFlyer wallet with the participating merchants, for example, and other merchants within that. So Citi, for example, Citibank. So you can link with your Citi rewards to allow for future transfer of points between the accounts. In the following stage, the customer can enter their Citi rewards account and transfer their Citi points into KrisFlyer miles using the present exchange rate. The customer can then scan the QR code provided by Starbucks in the airport and can pay with their KrisFlyer miles, which have been accumulated in their wallet. So again, there are benefits for all of the parties within this ecosystem, but notably for consumers, increased choice, lower transaction costs, resulting in an overall enhanced experience. Thank you. Now I know that was a brief whistle-stop tour into everything. More than happy to take questions from anyone. And again, thank you very much for listening. Hope that was valuable. Thank you very much.